Welcome to my video on equations using the distributive or commutative property on one side. So the first step in these types of problems would be to use the commutative or distributive property. The next step would be to combine like terms if needed. And then finally solve the equation. So let's look at some examples. So in the first one, look at both sides of the equal sign, and are there any like terms to combine on any of the sides? And the answer is yes on the left side here. So we're going to use the commutative property to get the 3x and the 7x next to each other. Keeping the minus sign in front of the 7x, then bring down the minus 11 equals 5. Now here are my like terms. So what's 3x minus 7x is negative 4x. Bring down the minus 11 equals 5. Now what we have here is a two-step problem. So we can circle our variable and draw our t. The opposite of subtracting 11 would be adding 11. So the 11s would cancel. Bring down your negative 4x, and 5 plus 11 is 16. And then finally, the opposite of multiplication is division, so we're going to divide both sides by negative 4. Negative 4 divided by negative 4 is a 1 in disguise, and x will equal negative 4. Now the key to these is making sure you check your answers. So if I were to check this, which I want you to do when you're doing your classwork and homework, you would take the x, which is negative 4, and you would do 3 times negative 4 in your calculator minus 11 minus 7 times negative 4. And then you would hit equals, and you would, in fact, get 5 for this side. So 5 equals 5, and that means it checks. Let's look at number 2. So are there like terms on any one side? The answer is yes on the left side here. So we're going to use the commutative property once again. So 5x, keep the minus sign in front of the 2x. Bring down the plus 7 equals negative 8. Combine like terms. So 5x minus 2x is 3x plus 7 equals negative 8. Circle your variable and draw your t. Now we just have a two-step equation. The opposite of adding 7 would be subtracting 7. 7 minus 7 is 0, so they cancel. Bring down your 3x. Negative 8 minus 7 is negative 15. And the opposite of multiplication is division, so divide both sides by 3. 3 divided by 3 is a 1 in disguise, so x equals negative 5. So once again, to check this, we would do 5 times negative 5 plus 7 minus 2 times negative 5. And then we'd hit equals, and you would get negative 8. So it does, in fact, check. Number 3, are there like terms on either side? And this time, they're on the right side. So bring down your 10 equals. Now we're going to move the like terms next to each other, but remember to keep the minus 9 in front. Plus 2x. Okay, combine the like terms. 5 minus 9 is negative 4. But before we do that, let's bring down the 10 equals. Now make that negative 4 and bring down the plus 2x. Now we have just a two-step problem, so circle your variable and draw your t. Now I know you see an addition sign here, so you're probably thinking, well, I subtract 4 from both sides. The answer is no. look in front of the 4. I see a -4, so I know to cancel out 4 negatives, I need 4 positives. So add 4 to both sides. These will cancel out because they equal 0, and 10 plus 4 is 14 equals 2x. The opposite of multiplication is division, so divide both sides by 2. 2 divided by 2 is a 1 in disguise, and 14 divided by 2 is 7. So 7 equals x. Okay, number 4. Are there like terms on either side? The answer is yes. Now they're back on the left-hand side. So -5, move the 10, plus 10, minus 5x. Now it's important to note when you're using the commutative property that you carry the sign that comes in front of the number you're moving. So notice I put the plus 10 in front of the 10. Now combine like terms. -5 plus 10 is +5. Bring down the minus 5x equals -2. Circle your variable and draw your t. And this time, notice I'm circling a minus sign, which means that 5x is really negative. Now, when I'm looking to get rid of this 5, I look in front of the 5. This is +5, so I'm going to subtract 5 from both sides because I want that 5 to equal 0. 5 minus 5 is 0. Cancel. Bring down your -5x. And -2 minus 5 is -7. The opposite of multiplication is division, so we're going to divide both sides by -5. -5 divided by -5 is a 1 in disguise. And you have 2 answers that you can write for this. This time my answer is not going to be an integer. So negative divided by a negative is a positive, so I can leave this as x equals 7/5, or I could do 7 divided by 5 and I would get 1 4/10. So anytime your answer does not come out to be an integer, you can write it as a fraction. The only time you can write it as a decimal is long as it doesn't repeat. Okay? If it repeats, then you have to write it as a fraction. We'll come across one later in these notes. Now to check this, I would do -5 minus 5 times 7 divided by 5. Remember, I would type this in 7 divided by 5. Plus 10 and hit equals, and you would get -2, so it does in fact check. Oops, and I forgot to put a check mark for this one. This one does in fact check as well, even though we didn't talk about it. Okay, let's move on to number 5. So in these next examples, we're going to be using the distributive property. Oops. Okay, there we go. All right, so we're going to distribute the 3 to both parts. And whenever you see a number outside of parentheses, you have to remember to distribute to both parts. So 3 times y is 3y. 3 times -4 is -12 equals 15. Circle your variable and draw your t. The opposite of subtracting 12 would be adding 12. -12 plus 12 is 0, so they cancel out. Bring down your 3y. 15 plus 12 is 27. Okay, the opposite of multiplication is division. So we're going to divide both sides by 3. 3 divided by 3 is a 1 in disguise, so cancel those out. And 27 divided by 3 is +9, so y equals 9. Now when you check these, you want to do the parentheses first, so I would do 9 minus 4 and hit equals, and then I would multiply by 3, and 5 times 3 is in fact 15, so it does check. Number 6, we have a -3 outside of parentheses, so distribute to both. -3 times x is -3x. -3 times +2 is -6, so I write -6 equals 7. Circle your variable and draw your t. The opposite of subtracting 6 would be adding 6. Negative 6 plus 6 cancels out and equals 0, and negative 3x equals 13. And the opposite of multiplication is division. Negative 3 divided by negative 3 is a 1 in disguise. And then 13 divided by negative 3 comes out to be a repeating decimal. So if that's the case, then I make sure I simplify 13 over 3, which it can't be. And I know I have one negative, so I can stick the negative in front of the fraction. So this is x equals negative 13 thirds. So when I check this, I have to do negative 13 divided by 3. And then I have to add 2 and hit equals, and then multiply by negative 3, and it will, in fact, give me positive 7. So it does, in fact, check. So anytime it comes out to be a repeating decimal like that, or a non-terminating decimal, I need to leave it as a fraction. Okay, so look at number 7. I have a negative 2 in front, so I'm going to distribute. Negative 2 times y is negative 2y. Negative 2 times negative 7 is positive 14. Bring down the minus 6 equals 4. Now, are there like terms? There are in this case. The previous two examples, there weren't after I distributed, but now there are. So I have to combine those. Bring down your negative 2y. And 14 minus 6 is positive 8 equals negative 4. Now we just have a two-step here, so circle your variable and draw your t. The opposite of adding 8 would be subtracting 8. 8 minus 8 is 0, so cross them out. Bring down your negative 2y equals negative 4 minus 8. I'm sorry, this is positive 4. I'm not sure. I stuck a negative in there. That should not be in there. I apologize. So let's fix that. This should equal positive 4. And 4 minus 8 is negative 4. Sorry about that. Not sure how I got the negative there at first. Okay, now the opposite of multiplication is division. So we're going to divide both sides by negative 2. Negative 2 divided by negative 2 is a 1 in disguise, so y equals positive 2. Okay, so make sure you fix that. For whatever reason, when I brought down the 4 here, I made it negative, and it shouldn't have been. So 4 minus 8 is negative 4. Okay, last example. We have number outside of parentheses, so we need to distribute first. Bring down your 12. 5 times 8 is 40. 5 times negative 2y is negative 10y minus 18. Now I need to move my like terms next to each other that are on the same side. So 40 minus 18 minus 10y. 40 minus 18 is 22. So 12 equals 22 minus 10y. Circle your variable and draw your t, and notice I'm circling a minus sign, so I got to make sure I keep that negative. Now I want to cancel out 22, so I have to subtract 22, because 22 minus 22 is 0, so cross that out. 12 minus 22 is negative 10 equals negative 10y. Opposite of multiplication is division, so we have to divide both sides by negative 10. The negative 10s cancel on this side because it equals a 1 in disguise, and negative 10 divided by negative 10 is 1, so it's 1 equals y. Now remember, to check this, I would do 8 minus 2 times 1, which is 6. And then 6 times 5 is 30, and then 30 minus 18 is 12, so it does in fact check. So make sure when you're checking ones with parentheses that you hit equals after you do the parentheses before you multiply by the number outside the parentheses. Okay, that concludes our notes on equations using the distributive property on one side. I hope you have a great day.